Okay, you're good to go.
Good evening, everyone. Welcome to the Introduction to Robot Operating System workshop. I'm Dr. Balasubramaniyan Chandrasekaran, and I will be presenting an introduction to Ros. And thanks to Dylan and the Robotics Club for organizing this event, where we can actually, present some of the tools that are used in designing robots. Okay. So I will be playing the videos that is pre-recorded on the robot operating system. And as the video is being played, if you have any questions, please feel free to interrupt me and ask questions. So this is part 1.
Hello, everyone. In this video, I'm going to be presenting the robot operating system, an introduction to the robot operating system. And we'll see what is Ros and how you can, or from where you can actually install the robot operating system. Now, the robot operating system is an open source meta operating system that can be used for your robotic application. You can get similar services like from a regular OS, but it also has hardware abstraction, device control, and some commonly used functionality. Message passing between processes, as well as package management. Now, it also provides the tools and libraries for obtaining, building, writing, and running code across multiple computers. So when we talk about building a robot or applying it in a robotic application, it's mainly with respect to you can have navigation, right? So it already has some existing, navigation, packages available. You also have like filters like Kalman filter, etc. That's also available in the Ros. So the main feature is that you have existing libraries, and you can actually use those libraries when you are writing your own robotic application. Now, Ros does not replace the traditional OS. So Ros will be like installed, let's say you already have Ubuntu, and then you then install the Ros. Okay, once you have the Ubuntu. Now, but Ros by itself is not an operating system. It needs an operating system like Ubuntu, in order to run. Now, it has packages like we saw earlier, but mainly for applying in several like robotic algorithms that has to do with path planning, then motion planning, obstacle avoidance, etc. Okay. Now you can also create and develop your own packages, and compile and then execute them. Now, robot operating system uses what is called as the master and the client nodes. So the communication basically happens by passing messages, and because of this, Ros is able to interface with the latest hardware, as well as any new implementations of the new algorithms. They're available, and they can be used in your when you're developing your robotic application. So. In short, Ros has several features, like in the form of libraries or packages, and then depending upon your requirement, you use them. Now, one important thing to note is Ros is not a programming language like C, C++, or Python, but internally, Ros uses C++ or Python in order to build build the application. So it's used within the Ros, the Ros system itself, but Ros by itself is not like a programming language like C or C++. Now, Ros is like a library which not just includes client libraries, but also there is a server. You can also have command line tools. And then we'll see some of the command line tools in the next video, where I'll be showing some commands which are specific to Ros. How we have in Linux, you can also have some specific Ros commands. And then there are also graphical tools that are available, and a build system. When I say a build system, you can use commands like cmake, and you can actually create your own package, and then you can use it for a particular application. Now, another thing is ROS is not an integrated development environment like Eclipse. So it's not like an IDE. Yeah? Instead, it's just like a normal, you open a terminal and then within the terminal you run the commands. So it doesn't have like a like an Eclipse kind of IDE. Okay. So all the information, you can see more information in this book called General Introduction to ROS by Jason O'Kane. So this is a very good book on like a simple a simple understanding for the robot operating system. Now the website is also useful. I also like the website, but this, if you are looking for a book, this is also a nice book. So from where do we install the ROS? So there are some links over here. So the first one is Ros Installation. Now, when you click on Ros Installation, it takes you to the most recent, ROS. So here you have Melodic Morania, and then you have the Noetic. Okay, so you can choose any ROS version of your choice. I personally installed it, the Melodic one. The Melodic one is the one that I'm using, but you can use any the new one. Okay, anything is fine, but make sure that you follow the the instructions, like if it's an Ubuntu or a Debian, okay, based on your OS. Now, ROS also has several APIs. So if you click on this link, it will show you the APIs. So it supports several client libraries, but the main ones are ROS CPP and ROS Python, because I told earlier that ROS applications are built using either C++ or Python. So therefore it uses the ROS CPP and ROS Py. But there are other packages as well, like shown in this particular website for different applications. So for example, if it is for let's say for actions, so it uses ActionLib, which is common. Then for navigation, it uses the navigation stack, and then that's through ActionLib for both the C++ and Python. So again, there are several APIs that are available for the in the ROS system. Now, in case if you want to practice any tutorials, so you can click on this link. That's ROS tutorials, and that is divided into beginner and intermediate level. For the ROS application development. Now, we will be doing some in the next video. In part 2 of this video, I will be showing some of the commands and executing a package, okay, in the ROS. And then if you're looking for ROS CPP tutorials, particularly like the C++ tutorials, then you can use that link. And then so this has some basic tutorials on how to write a simple publisher and a simple client, a publisher and a subscriber using C++. And also writing services, as well as like writing a simple service and a client. So these are some of the useful links that are that can be that will help you understand the basics of the robot operating system. Again, as a summary, ROS is not a programming language, and it's also not a standalone operating system, but it is used along with the Ubuntu. So you have to install Ubuntu first, and then you have to install ROS on top of it. And ROS basically can help in making the implementing the robotic system through the motion planning algorithms, as well as the navigation stack and so on. Okay, so in the next video, in the part 2 video, we will see some commands in ROS, and I'll show how to run an existing package available in the ROS system.
So that was part one of the video. I'm seeing a comment.
Yeah, we did get one question. Somebody asked, why is ROS used mostly with Linux?
Okay, so ROS is used mostly with Linux because it was designed initially to be used with the Linux operating system or the Ubuntu operating system. So that is the reason why it was designed for Linux. So that was the initial development for the ROS.
Awesome.
So we can move on to the second part of the video, right?
Yeah.
Okay. So now the second part of the video I'll be playing. In this part, I'll be showing some commands and how to execute an existing ROS package.
Hi everyone. In the previous video, we saw the basics of ROS, an introduction to ROS, and then from the links from where we can actually install the ROS, okay, the latest version of ROS. So once you install ROS, the next step is you can just verify the path where it was installed. So for that, you can use the command. Okay, so this will give you the name of the version. So here it is basically melodic and the location where it was stored. Now, ROS has several commands that are very similar to the regular Unix or Linux commands. Now let's take packages. So we know ROS has several packages within the file system, and if you want to look for a particular package where it is stored and you want to go into that particular package, so you can say ROS pack find and then the name of it. So for example, you can do ROS CPP, which is a package, and then I can also do ROS LS. I can also do ROS CD. So this will take me directly into that particular folder. And now, similar to the ls command in Linux, where we can list files, you can use ROS ls. And then it will show you the existing, the files within the particular ROS package. Now, you can also into the log file. Now, the log file is a very famous file because pretty much once you start the communication, the application, you have the master and the other clients communicating among themselves, you will have a log file where the data is constantly being updated, when information is updated. So if I do ROS, here it's showing me no active ROS core because I haven't started the master node yet. Okay, once I start the master node, then there is some kind of an application running. One important thing with ROS is you need to have the master node running before you start any of the other application nodes or client nodes. Okay, because master is the one that actually coordinates all the other nodes, the communication between the other nodes. And so let's say I do ROS ls. Now it is going to list all the log files that have been that are existing into this particular folder. Okay, so anytime I want to come out of this, I can actually use cd and then space tilde. Okay, and this will take me to the root directory, and then you also have another famous package called as the Turtle sim. So the Turtle sim is another turtle bot simulator through which you can actually give commands to the turtle bot. It's actually like a turtle, and then a turtle work an animal which represents like a robot to for navigation So you can also use ROS CD. I think the ROS CD will basically will take you into that particular folder. Like here, for example, if I just do Ros CD, it is taking me to the develop. That is the next, upper level folder. So in this way, you can actually have different variations. So you can have Ros Pack, that is Ros and then the package, and then you can have Ros CD, where Ros is the keyword, and then CD is basically a change directory, and then you can also have Ros LS, which is basically Ros and then the ls command that we use, even in Linux and Unix. So once you're done with this, the next step is to create the Ros package. So Ros package is usually created using the catkin command. So you use the catkin command, and then you can do catkin make, and that will generate the corresponding corresponding folder. Okay, the corresponding folders with the source, the development, as well as the other dependencies. Okay, so the next thing that we want to see is some of the other existing commands. Now, I told you that Ros basically needs to have a master node, and then you also have client nodes. Okay, so the first step is to actually start the master node, right? So let me just clear the screen over here, and then let me do cd space tilde, and then okay. Now, first I'm going to start the Ros core. So that means this is starting the master. Now, I can also list the current nodes that are there in the system. To do that, I can use the command called Ros node and then list. Okay. Now I only have the master node running, and that is why you're seeing slash Ros out on the screen, because there's nothing else running. There's no other client node that is running. Now you can have several other client nodes. One such famous or the one that's already available is called the TurtleBot simulator. Now the TurtleBot simulator, basically what it does is we see with the help of a command. So to run any client node, you need to use the command called Ros run, and then TurtleSim. TurtleSim is basically the package, okay, inside which that particular application is. Okay, and then we need to create an instance of the turtle, right? So for that we need to create a node called TurtleSim node. So okay, so what I'm doing right now is I don't have to type the whole word. I can just type a few alphabets, and then when I press the tab, it'll automatically pre-fill for me. Okay, so if you have done the Ros installation correctly, then probably this should autofill. Okay, if it's not auto completing, that means there's something wrong with the installation. Okay, now what this will do is it will create a node that resembles like a turtle. Okay, like a turtle, the animal. So we can see there is a turtle that is created over here. Now the purpose of this particular module is that you create a robot like a turtle, and then we can control it. Right now, to create the turtle itself is one node, but to control it we need another node. Okay, so again we have to use Ros run. Okay, now Ros run will be the command followed by the same package, right? So it will be under the TurtleSim. So what I'm doing now, I'm just typing turtle, and then if I type S, it will auto complete now. Okay, when I press the tab, and then I have so turtle teleop key. So that I'm controlling it through the keyboard. So I'm just typing T, and then I'm pressing a tab. It'll autocomplete. Now what this will do is it'll give me some options by which I can move the turtle. So it's asking me to use arrows to move the turtle. So I'm pressing the upper arrow key, and now I'm pressing the left arrow key, which is basically turning the robot in a different angle. And now I'm pressing the right key. and then again the left. So I'm just randomly moving the the robot. Now here you can see the robot is saying hitting the wall because I'm touching the borders over here, right? So that is the reason why it's giving me that error. Now if I keep moving this way, it's not going to show me those errors. Okay, so this is a default program that is already there inside the inside the Ros installation. Now, the thing is, you need to actually run each of them on a separate terminal. Okay, run each of them on a separate terminal, and that will basically, like, in that way, you know what are the different nodes in the system. Now, let's say if I open another terminal. And now if I type Ros node list, so I have 3 nodes, including the master node. So the first one is Ros out, which is the master, and then we can see the Teleop Turtle. So basically this is this, the keyboard, like, the keyboard option. And then the turtle sim itself, which is the, this blue color window, okay, which is creating a turtle, robot. So the Ros node list will always tell you what are the current existing, nodes in the Ros system. Okay. Now, the next command that you can actually use, so we saw a Ros node, then we saw Ros run, then we saw Ros core. Now, you can also use a command to basically to ping, specific nodes. So for that, you can use Ros. You can use a command called Ros node, and then ping my turtle. So here, this is an unknown. This is an unknown node. So, but if I type Ros node ping it is actually getting a reply, so basically you always have to give something that is already existing in the in the system, so that you can get a feedback. So here you can see it's pinging that particular turtle sim along, and it's getting the response. And I can do Control C. So for most of the commands, you can't just use autocomplete. You need to specify what you're actually looking for. So that is another feature. But so by using this ping command, I think you can always identify if a particular node is alive or not, right? So that will be that's one of the advantages of the Ros command, of this particular Ros command. So in summary, you have the Ros core, which is the Ros plus core, which is the master. You need to start that first, and then you have the Ros node. So basically that will give you information about that particular node. Okay, and then Ros run is used to run a node from that particular package. Okay, so those are the 3 important commands. Now, Ros basically uses a master, and then it communicates with client nodes. Now, sometimes it's necessary for you to have a graphical representation, because you're having so many nodes, right, in the system, and you need to have a graphical representation. So for that, you need to have a graph, right? So I'm going to clear the screen. So to represent these represent the relationship between all these nodes, you have to run what is called as the RQT graph. Okay, now the RQT graph is also like another, think of it like another client node. So you have Ros run and then RQT and then space G. So RQT and then underscore GR, then it will automatically complete for me, and then RQT graph. Now if I run this, let's see what's going to happen. So it's showing me that there is a turtle sim node, right, which is basically the default node over here, and then the Teleop Turtle. So basically, the Teleop Turtle is now sending this command velocity, which is basically a topic. So again, since it's communication between the nodes, the communication between the nodes happens through, like, you have, like, the nodes will actually subscribe to a topic, and then so some nodes will actually publish on that particular topic. So here turtle sim will receive the command velocity from the teleop. Okay, so it keeps listening to it and then it gets the command, and so this is the RQT graph for this simple representation, for the simple example. Okay, now Ros topic, you can also have several, it gives you information about the Ros topic, that particular topic. Now to run that, you can use, let's say, here I'm actually having the master node. So let's say for now, I'm just going to exit this. So I can use Ros topic list. Okay. When I use Ros topic list, what it's going to do is it's going to show me all possible topics that exist in the system. So here, like, you have Ros out aggregate, statistics, command velocity, and so on. Okay, you also have the post information. So it'll give you information about that particular topic. Like, you can always query that particular topic and get more information about it. Now, you can also use commands like Ros topic and then echo. So if you can say Ros topic echo, and then this will basically give you information about that particular topic. For example, if you just type this, it'll give you an error because you need to specify the topic. So you can give any topic name that you want. For example, you can say / something. So here, yeah, command velocity. Here, it's not displaying anything right now because I actually already deleted the process. But in general, what will happen is you will be getting the numbers here, like, what the values for that particular velocity are. So you need to specify the name of the topic so that you'll get more information about the topic. And another thing that I wanted to mention is Ros topic list. We saw you can also have information like say you want to know more details, right? Then you can actually use the -v command, -v option, and that'll give you more details about the particular topic. Okay. So, and it tells you what is the publisher and what is the subscriber, right? So the subscribe topics here are the command velocity, and then you also have the turtlebot post, which is the publisher. So basically, this will tell you if you want to know the difference between the published and the subscribed topics, then this will help you. Okay, this command will help. Now, the next thing is you can also specify the Ros. You can also get the Ros topic, the type of that particular topic. Okay. Again, I think this is only valid for the latest one. I think if you're trying to use an older version like before Indigo, I don't know if it will work, but anyways, you can try this. Okay. So Ros topic type can also be used. Now, one more thing that I wanted to specify, specify was the rate at which the data is published. Now, for that, you can say, let's say you have Ros topic, and then you can also say hertz, HZ, and then / turtle one, and say you want to type the post. Here So here it's telling you the rate at which it's being published, right? So this will give you the information about it. Okay, the average rate at which it's being published. So there are several options like this, to specify what you want, what kind of what the topic is, and more information about the topic. Now, one last thing that I want to just mention is you can also plot the pose position of the robot, like the XY. You can also plot the angles. For that, you have a command called, let's say, I'm going to stop this. Ros run rqt_plot, okay, and then rqt_ it's the same name, okay, rqt_plot. So here it's not showing anything right now, but because I already deleted the process. But what happens is you will be able to see the X and the Y coordinates happening, of the pose. So in that way, you can actually get an idea as to what is happening between the X and the Y coordinates, X and the Y coordinates of the pose of the robot. So I think with this, I've kind of tried to do some of the basics of the ROS. So if you refer to the previous video, again, it gives you some basic information on the robot operating system, as well as installing the ROS. In the future, I'll make another video on on the CMake command, as well as the dependencies, as well as more details on how to custom write your own C++ program, and create your own package, and then develop your own application in ROS. Okay, so again, this is just like a simple introduction to ROS. My suggestion is to please go to the website that I showed in the previous video on wiki.ros, and then that will give you more information on how to apply ROS. Okay, so thank you.
We did actually get a few questions during that time.
Oh, okay. I think it was on full screen mode. So basically what happened is I don't see the comments, right?
That's okay.
Sorry about that. Let's
No
see.
worries.
Okay, 2 new questions, and so let's see.
Do you see the questions?
Okay, is having 3? Oh yeah, I can see the questions. Yeah.
Awesome.
Is having 3 or 4 questions open at the same time required for programming them? Well, 3 or 4 windows is not required, but what happened in the case of the tutorial, like you can see in the video that I was showing, is that I was trying to show the master node along with the other client nodes, and that is why each client node has to be run on a separate terminal, or you can call it as a separate window. That's something that you have to do. So, but it's not required to have 3 or 4 windows at the same time. I had the windows open because it's easier for me to type, the commands easily. Okay, but you can always open the first terminal, and then you can open the second and the third terminal, and then do it. That's fine. The next question is, how difficult is ROS to get into if you have limited experience with programming? Now, with ROS, you need to have some basics on the Linux. Okay. Now, once you know the basics of Linux, what is the Linux commands, and then shell scripts, like the make command, then you can move into ROS, because ROS is purely it's based on several similar to the Linux commands, right? We saw ROS ls, ROS cd, and so on. If you know C++ or Python, it's easy, because ROS ROS applications can be built using either C++ or using Python. So if you have to go into writing your own publisher or writing your own subscriber, then you should know either C++ or Python. Okay, so that is that's the experience that you should have with programming. Now, the next question is there somewhere we can see a list of all these commands? Yes. So I was showing you the tutorials, right? The link to the tutorials, like wiki.ros.org/tutorials, I believe. So anyways, so if you go to that link, it'll give you it'll show you the set of steps. And then inside that, you will have the commands. But even if you just go and do a Google search on ROS, cheat sheet, it'll give you each there are different people, they came up with their own custom cheat sheet where they have the most frequently used ROS commands, and also they also have some Linux commands as well. So you can always do a Google search and that will give you a summary. But if you always want a comprehensive list of all the commands, then of course you should go to wiki.ros.org and they have all the commands there.
Awesome.
So I think, yeah.
Yeah, that's all the questions I see. Is there anything else you'd like to cover during this workshop?
So basically, I wanted to say that with ROS, if you practice the tutorials from the website, I think that will give you a good understanding. But there is lots to learn in ROS, and so it's basically like writing your own application, developing your own robotic application. So the first step is to start from ROS, and then once you get familiarized with ROS, like you're writing your own publisher and subscriber, and then you can actually extend it and see more about the visualization tools like RViz. And then Gazebo, those are additional things that additional software. RViz is a part of ROS, but Gazebo you can actually later on you can do more visualization by using RViz Gazebo. So again, C++ and Python is something that you should be familiarized with, if you want to build applications with ROS. So that's what I wanted to say.
Awesome. Then I think that brings us to the end of this workshop. I don't see any new questions.
Yeah, I think so. Yeah, I think there are only 4 questions, I believe, right? We got 4 questions.
Yes.
That's good. Okay.
Awesome. Well, thank you, Dr. Bala, for your time. This was really useful, and I think a lot of people will learn a lot from this.
Right. Thank you, Dylan, and thanks to the Robotics Club for organizing this workshop. So this is very educational, and a lot of people can actually learn a lot from this and build their own robotic applications, and that would be great.
Yeah, definitely. Thank you.
Thank you.